Hello friends, today is very exciting. We're going to do our first DIY solar generator build. So today we're going to build something very similar to the Jackery 160. We're going to use a 204 watt hour Miady 16 amp hour lithium iron phosphate battery. And we're going to use all of the components you see in front of you and mount them against this wooden panel to create our own basic solar generator. Now in the next video, we'll probably go ahead and put this into a container, seal it, and get a little bit more protection. But let's just talk about the basics of how to wire and how to build your own solar generator. So first, we need some basic tools. A wire cutter and a crimping tool. Now, we can see individually how to use these in our Let's Build Wire Connectors video. So I won't go into detail on that with this video. The next is our 3-gang marine boat rocker switch panel. I really like the USB outputs here, how we can monitor our voltage, and these switches, which will enable us to toggle on or off our USB ports and our DC output. Obviously, we have our battery. Now we have our inline fuse system. So this allows us to put an automotive fuse directly in line. So when we cut this, we'll have one side of the circuit and the next side of the circuit connected by the fuse, so we can protect our lines to our battery, to our solar charge controller, and to our appliances. Here, we have a terminal block. Now this terminal block is going to serve as our bus bar system. We can use this to connect these 4 different terminal blocks, terminal systems, and make one effective bus bar at a much cheaper cost. Now, for the inverter for this build, I've chosen to go with a standard car inverter at a 150 watts. This is a modified sine wave inverter, and it will perform very similarly to Jackery's 100 watt modified sine wave inverter. But, because we'll be using a 12 volt DC adapter to plug it in, we can also have a full-sized 12 volt output on this build. Now, we won't be able to run them simultaneously, but frankly, considering the limited output of this battery, we probably wouldn't have that use case. We'll be using Anderson connectors to connect to our solar charge controller, and throughout the build, we'll be using these F2 connector terminals to connect to our battery and other areas of the build. Finally, the most important piece is the pencil. This is how we can do all of our drawings and markings to make sure that we're doing everything correctly. We're putting the holes where they need to be, and we're getting an effective build done. So here I've just taken some scrap wood to create the basic frame for our system. I've mounted a 2x4 to the bottom to provide a sturdier base, and then I've just got this flat panel on top. Now, you'll see that I've already drawn out some of where I want my pieces to go. Basically, what I did, I took my handy-dandy pencil and I aligned with the wood to draw out the location of my holes. Now, there's another way that you can do this very easily. Now, personally, I think it's super easy to just unscrew. So now that we've removed all the components, I have a stencil that I can create. So I can just set it on the board, and I can draw out the outline for all of my component pieces with my pencil. I can also use that same stencil for the location and outline of my 12 volt USB output. So I can just draw another hole here. Finally, I can mark the location for my charge controller. So I can do the same thing, marking the screw holes and where my output lines are going to be. So we can see my output lines and my 4 screw holes. The next step is to take this outside and get to cutting. So now we've got all of our components mounted on both the front, so our 4-gang switch, our DC output, and our solar charge controller, and in the back with our 2 bus bars. Let's get wiring. Okay, so the first thing we're going to do, which I've already done here, is install our bridge for the terminal block. So we have that in, we have it screwed down nice and tight. The next thing we're going to do is take our first inline fuse line. Now, when we're fusing to the battery, you always want your fuse as close to the battery as possible. So we're going to cut this just shy of the battery, giving us just enough space to put a terminal connector, and then we'll run that to number 1 on our terminal block. Now, for this, we're going to use the F2 connector. And because this is insulated, we're going to use our insulated crimping side. Now, because this is also a heat shrink connector, I'm going to go ahead and heat shrink this, but we'll fast forward through this in the video. Now, for our other end, we're going to use the insulated connector that came with our terminal block. So, again, I'm going to cut the end here. And again, using the insulated section. I think I went a little too hard on this one, so I'm just going to cut this off and do it again. We have a secure connection here, but I don't really like these terminal connectors, so I'm actually going to add a layer of heat shrink on top of that. This step is definitely not necessary, but if you want to go the extra mile and just kind of ensure that you have not only a really well-functioning device, but a good-looking device, you can always heat shrink your connection. So now I'm much happier with this. Still a little warm. Go ahead and let that rest a bit. So our heat shrink is cooled. We're just going to install this into bay 1. Nice and tight. Very happy with that. And so now we have our positive bus bar started. What we're going to do is wire our different objects from this bus bar. Well, technically, because we have the switches, we're going to wire power up to the switches, and then from the switches we're going to wire them to our different components. But you'll see all of this, and we'll talk through it as we hit these next steps. Alrighty, so we've repeated the process here with our second fused line. This is the line that's going to run to our switch that controls the voltmeter and our USB. So now that we've got this line going from our bus bar to our battery, let's connect this. For this connection, we'll be using the cables that came with the 3-gang switch panel. So I'm going to connect to the positive, so we're looking for that positive, and then to the positive again, and then finally I'm going to connect down to where we have our connection to the bus bar. So this is the switch. In this configuration, when we turn on the switch, we're going to get power to these two systems. But first, we have a lot more cables to connect. Now, our 12-volt adapter actually comes with a cable that has, you guessed it, its own inline fuse. So, we can be a little lazy with this one. And plug this in to our positive here. Now we have a lot of extra cable here. And we have a connector that we can't really use. So, what I like to do in this situation is just cut my cable, get rid of all that excess slack, and then here we can find our gauge. Get a little bit more. And what we can do is actually connect this directly to our terminal block without using a connector. Makes it a little easier for us. You know, honestly, looking at this, I don't like the gauge of this wire for how many amps we're going to be putting through this. So, I would much rather just discard this cable. And we're going to use one of our 10 gauge. So we're going to take our 10 gauge and we're going to add a terminal connector. Got a little hot on the wood. Right, I forgot we were actually switching this. So what we're going to do is pull this from here. Put it into our top row. So that we get a good connection here and here. Now we're going to run a short line from here to here. Because we're fusing this, I'm not really worried about needing to run a fuse from the switch, so we can just take that extra piece of wire we got from this, measure, and see where we need to go. So while we're waiting for our new cable from the switch to the DC output to cool, we can do our negatives. So for the negatives, we'll be working with the cable that arrived with the 3-gang switch panel. Now I've already crimped on the connector for this cable, so we can just plug in our negatives here. And this is our first connection to our negative bus bar. It's very exciting. screw it down. Now each time we have a positive cable, we're also going to have a negative cable going in so that we can complete the circuit. So the next place we're going to put our negative cable is so the next negative cable we want to run are up here. Fortunately, we again have another cable that was provided. So we can just connect these all along the top, even though we won't be using this one, it's still fine. And because we have a smaller gauge wire here, we can actually just directly connect to the bus bar. So we can slide this in. And tighten it down, making sure it's good and tight. Beautiful. Now we have our negatives on all of our switches and on our USB. So the last thing to run is our negative from our 12 volt and then our negative from our battery. So to run our negative to our terminal block and our battery negative to our terminal block, we need to make some tough decisions. Now, we can sacrifice some of our fused lines and just run them connected. The color doesn't matter. We could even mark it with black heat shrink or a black marker. However, my preference is to just grab some 12 gauge wire. I have a lot of 12 gauge wire from various projects I've built, and if you are interested in building DIY solar and other pieces of equipment, I highly recommend just grabbing a spool of 12 gauge wire. So we're going to use some 12 gauge scraps that I have lying around left over from other projects. Alrighty, so we have our final cable. So let's make sure our positives are disconnected, everything is disconnected. See if we can connect it to the battery. It looks like it'll just fit, which is perfect. Of course, I forgot to heat shrink this one, but it'll be fine. So we can connect our negative post. Let's cover up each of our terminal blocks. And then we'll do our final connection to our 12 volt output. Okay, so we now have everything connected. We have our negative lines running to our USB out and our voltmeter. We have each switch with its negative, and these are both connected to the negative bus bar or terminal block. We have our negative out coming from our 12 volt output, and we have our negative line run to the battery. We also have our battery positive line, which has the fuse right next to the battery positive. We have our 12 volt output line, which is our fuse closest again to our battery. We can connect this. And we have our bus bar fuse to our USB connection. So this is connected up here. So if we trace each red line from red positive battery to the bus bar, from the bus bar up to our switch, and then down to our 12 volt, and from the bus bar to our switch, and then up to our USB and our voltage monitor. So now, all we have to do is fuse each of these lines, and we'll choose our fuse size based on what we expect to pull. So our largest fuse is going to be at the battery. Now this is a 16 amp hour battery, and although it can actually output, I think we tested this one for 475 watts, which is 2.5-ish times the capacity, we're going to put a 20 amp fuse into this, as I really don't want to exceed 20 amps, and none of the equipment we'll be using gets anywhere near that. So this will protect the battery. It'll stop us from overcharging and over discharging. So now we've got our first fuse in. We can close it up, and we have power, except we've got fuses along the line that also need to be added. So I'll disconnect this so we're not working with any live wires. Now the next line is our line going to the switch that goes to our DC output. Now this is capped at 10 amps, so I'm going to throw in a 15 amp breaker. You might ask, why don't I just use a 10 amp breaker? Because I don't want it to trigger at 10 amps, which is the maximum capacity. I want it to go just slightly over. That way, if there's a large surge current, it'll still stop it, but it won't stop it from pulling maximum capacity out. Finally, we have our USB device. Here, I am going to use a 10 amp breaker. Even though this USB output only does a maximum of 4 amps, I just like using a 10 amp here. There's no particular rhyme or reason. If we go with a 5 amp breaker, we'd probably be fine. But 10 amps gives us some wiggle room to play with. Now we've got all of our fuse blocks in. We can do the honors of plugging it in. So now we're positive. And we can rotate our panel. Da-na-na-na. Forgot to wire in our charge controller. So right now, purely off of the battery, we have our 3 switches. Switch number 1 goes to our voltage meter and our USB output. Switch number 2, we'll use our inverter to test this, goes to our 12 volt power supply. So now we can run our inverter with the flip of a switch and check our voltage and power our USB devices. Let's finish this up by connecting our charge controller. Alrighty, because I forgot to wire in the solar charge controller, we're going to make one adjustment to this top little terminal block. Here we've got our 14 gauge. I've already removed the connector from this, and we're just going to wire both of these 14 gauge into this terminal block. So now we've got these both secure and tight. We can add our one more cable necessary for the solar charge controller. So we'll grab another piece of scrap 12 gauge, and it is more than long enough, so we're actually going to cut that down to figure out exactly how long it needs to be. Wire this under here. Got more than enough slack here, so we'll cut it about this point. And this is how you end up with scrap 12 gauge. hopefully, for the last time, we'll apply our cap. Now we're going to do the same thing for our cable here. Now, you can absolutely use your fused wire. And that's what we're going to do in this case. But because we already have a fuse going to the battery and a fuse to every appliance, you don't technically need a fuse at the solar charge controller as well. Because we have these and we want to be extra safe though, we're going to go ahead and use that. Alrighty, so now we have all of our connectors in and connected. We can lock this up and we'll run our wire through. And we are out. So, to connect our solar charge controller, we have this handy dandy output guide. So here, we want to take our positive into our positive battery terminal, our negative into our negative battery terminal. Very simple. We'll cut these down again. Okay, so now we have our positive and our negative connected to our solar charge controller. We're going to once again plug in our battery positive. Oh, wait. Let's first fuse this line. Now this is a 20 amp solar charge controller. So again, I don't want it to go overboard, but I also want it to be able to max out if necessary. So we're going to use a 25 amp fuse. Connect that fuse. We'll cap it, and we'll connect our battery. And do a better job of securing our battery negative. Okay, we're all connected. We've got our fuse in, so we can connect our battery. Positive. And we have life. So we can see that our voltage here is matching our voltage here. And now we can do our solar in, our final step. Now, if you recall, we had this scrap piece of 12 gauge. Now we're going to turn it into our solar input connector. And then using our Anderson connector, yes, they've been sitting over here all this time, but that moment has finally come. We can reconnect our battery, because we always want to turn the charge controller on from the battery first. Turn off our voltage monitoring. And let's connect some solar power to it and see if it's working. Alright, so we have our positive in, our negative in. Let's see if we've got solar input. Looks like we do. Our battery is charging. We can see that we've got 13.5 temperature. We have 3.6 amps coming in to the battery right now. Nothing going out because we don't have a load through here. Our max charge setting, our discharge settings. But yeah, very nice. So we've got solar in. We can see how it's affecting our voltage. We're now up to 13.6 because we have that huge 200 watt array feeding into this battery right now. We can pull power out via our USB, or we can run our inverter off this 12 volt car adapter. So if you've been following along and building with me, you now have a fully operational solar generator. You can charge your battery, you can run small devices, and you can use your solar panel to generate AC energy. The next thing we're going to do with this build is take it from our panel, our test setup, and move it into a container so we have a full containerized battery. Thanks for watching.